Math 110, Application Models, Growth and Decay with Compound Interest, Section 5.6. The first real-life example that we're going to be looking at is going to be with population growth. Now, the way that we model population growth is going to be with this function here, where k is greater than 0. Now, to kind of label what these elements mean, p sub 0 is going to be the population at time 0. Your p of t, or just your population p, is going to be the population after time t. And then k is going to be our exponential growth rate. So now we're going to apply these concepts. So on our first example, which is right here, this says that in 2013, the population of Ghana, located on the west coast of Africa, was about 25.2 million, and the exponential growth rate was 2.19% per year. It's asking us to find the exponential growth function, estimate the population in 2018, after how long will the population be double what it is in 2013, and at this rate, when will the population be 40 million? So our first one says find the exponential growth function. So what we need to assume is that at t equals 0, which is 2013, that population was 25.2 million, which means my p naught was 25.2 million. Also, it says that my exponential growth rate was 2.19%. So in decimal form, I can say that my k is going to be 0.0219. So plugging those two elements into my function, my p of t is going to be 25.2 e to the 0.0219 t. So I wrote it as a function that models t as my input. So then part B, it says estimate the population in 2018. So I need to consider, if I'm starting at 2013, that means that my t is going to be 5 because it's asking for the year 2018. The difference between 2018 and 2013 is 5. So all it's asking us is to plug in 5 into for t. So if you enter that in your calculator and simplify that, you're going to get 28.1 million in 2018. Part C, it says after how long will the population be double what it is in 2013? So if I know that my initial population is 25.2 million, that means that it's going to be double to 50.4 million. And so I can say that my P of T is going to be 50.4 million. My initial is still 25.2 million, but it's asking what is my T value? What time is it going to be double? So now I'm just going to solve for T. So I want to divide both sides by that 25.2 million. So then I get 2 equals e to the 0.0219t. Then I need to take ln to both sides. Now the ln and the e are going to cancel out. That's why I wanted to do that. And so now I get ln of 2 equals 0.0219t. Now I can divide both sides by 0.0219. And so I get t equals ln of 0.0219, because it cancels out here, and 31.7 when I enter that into my calculator. So I can say that the population will double 31.7 years after 2013. Now part D says at this growth rate, when will the population be 40 million? So basically it's just saying plug in 40 million for my P of T. So I do the same thing. Get E by itself by dividing both sides by 25.2. Now instead of simplifying this because I want it to be an exact value, I'm just going to leave it like that. Then to get rid of this E here, I want to take the ln of both sides because the ln and the E will cancel out. And so I'm going to get ln of 40 over 25 5.2 equals 0.0219t. Divide both sides by the 0.0219. Do that to both sides. And so this value here, you want to enter into your calculator, and you're going to get approximately 21. So then I can make the statement that the population will be 40 million 21 years after 2013. Now we're going to examine compound interest. Now, one of the things with compound interest, I just wanted to point this out first, our equation is the same thing, okay? And when we're looking at compounded continuously. So when interest is paid on interest, we call that compound interest. So suppose that amount P sub 0 is invested in a savings account at interest rate K, compounded continuously, we're going to use this equation, and it's going to be after some t years. So for example number 2, it says suppose that 2,000 is invested at interest rate K, compounded continuously, and grows to $2,504.65 in 5 years. Find these 4 things. What is the interest rate? Find the exponential growth function. C, what will be the balance after 10 years? And D, how long will the $2,000 have doubled? So looking at A, what is the interest rate? So we need to pull some information first. So I know that my starting value is going to be 2,000. So that's why I said my P naught is going to be 2,000. Then I know that it grows to this amount in 5 years. So I can say that my P of 5 is $2,504.65. So I can substitute those values into the equation, and so I'm going to get $2,504.65 equals 2,000 e to the k times 5. Because it's asking for the interest rate, now I want to solve for k. Divide both sides by 2,000. Then to get rid of that e, I want to take the ln of both sides so that ln and the e cancel out. So I'm going to get ln of this amount equals 5k. Divide both sides by 5. And so I entered that into my calculator, and my k is going to be approximately 0.045, or I can say 4.5%. Now it might be nicer to leave it in this value because that's going to be what we're going to be plugging back in to answer our other questions. So part B, it says find the exponential growth function. So I need to substitute the k that I got into the function, and I get that value there. This is my P naught. This was the k that I had just found, and it's a function as it represents t, or the input t as it relates to whatever value after t years. Question C says, what will the balance be after 10 years? All I need to do is plug in 10 for t, and when you simplify that, you're going to get $3,136.62. Part D, it says, after how long will the 2,000 have doubled? So if I enter my original amount, what it's asking is for that to have been doubled. So that would be 4,000. So now I'm just solving for t. Divide both sides by 2,000. Take the ln of both sides, so those will cancel out. Ln of 2 equals 0.045t. So now I'm going to divide both sides by 0.045. And so entering that in your calculator, it's going to take about 15.4 years for my amount to have doubled. Now, kind of examining doubling with populations, we should have seen like a pattern that's going on. And that pattern would have been, well, if I have some original amount, all this was 2 times that original amount. And so if we look at it in this perspective, we could actually derive a few equations. So divide both sides by my P sub 0, because they're going to cancel out. Then take the ln of both sides, because I want to get this to cancel out, and so I get ln of 2 equals kt. And now I can divide by k and I can get this t by itself. And I can say that the time that it takes to double is always going to be ln of 2 divided by my growth rate. And sometimes when we write it in this form equation, we use this capital T instead. So you might see some books use that. And I just wanted to put in there just to make sure. And so if I manipulate this equation here, I can get it into these different forms. So these different form equations were all derived from that single equation that I got here, t equals ln of 2 over k. And so we get those three equations. So for this third example, it says the population of the Philippines is now doubling every 37.7 years. What is the exponential growth rate? So I want to use this equation, k equals ln over t. All I need to do is plug in 37.7 in for my time, simplify that, and so I'm going to get 1.84%. And that's the k that I'm looking for. Now sometimes we're going to be modeling limited growth, and the idea with this is that whatever it is that your function's doing, there's some asymptote, and your function is kind of like, it's going to approach that asymptote, and it will never pass that. And so we call that a logistic function, which means that it has some sort of limited growth. And that limiting value is going to always be that value there on A. Now in this class, we're not going to necessarily practice creating these, but we're just going to practice using them. Example number 4, it says that a lake is stocked with 400 fish of a new variety. The size of the lake, the availability of food, and the number of other fish restricts the growth of that type of fish in the lake to a limiting value of 2,500. Population gets closer and closer to this limiting value but never reaches it. The population of fish in the lake after time t in months is given by this function. So this is the modeled function that's going to be given to you, and it's asking find the population after these months. Now remember, t in this case is going to be modeled in months for this specific function. So all it's asking us to do with that function is to plug in 0 for t, plug in 1 for t, plug in 5 for t, plug in 10 for t, plug in 15 for t, and plug in 20 for t. And so all I did is you just plug the value in there, enter that in your calculator, and you're going to get approximately these values. Now notice I didn't write any decimals because I'm not going to have half a fish floating around in my pond. The other thing to kind of think about is look at the growth in 5 months that happened in this interval versus the growth in this interval, the growth in this interval. The growth was much more substantial in this initial part than the end. And the reason is there's a larger pool of food for these fish to feed off of. There's not as much competition amongst their species. And so because of that, you saw a much more substantial growth versus it over here. Now we're going to be looking at exponential decay. Now notice, even if we're using exponential decay, it's going to be the same as these equations are going to be the same for half-life. And so a way for us to express that, if I said my half of my original equals my equation here, and if we're representing this exponential decay rate, my k is going to have a negative in front of it. Okay, so it's going to be negative kt, and that's going to represent that decay rate. So once again, I can cancel out my p sub 0 or my initial population, and so I get 1/2 equals e to the negative kt. Take that ln to cancel out the e's, and so I get ln of 1/2 equals negative kt. Now I can manipulate this 2, so I can have ln of 2 to the negative 1 equals negative kt. I can bring that negative 1 to the front, so I get negative ln of 2 equals negative kt. Those are going to cancel out, so I get ln of 2 equals kt, which is going to be then further manipulated into one of those other two equations that I have there. So just understand that even with this half-life, this relationship holds. Okay, this relationship holds. So our fifth example, it says the radioactive element carbon-14 has a half-life of 5,750 years. The percentage of carbon-14 present in the remains of organic matter can be used to determine the age of that organic matter. Archaeologists discovered that the linen wrapping from one of the Dead Sea Scrolls has lost 22.3% of its carbon-14 at the time it was found. How old was the linen wrapping? We first need to find K, when the half-life T is going to be 5,050 years. Because the information, it gave us a percentage of how much is left, okay, by saying that this is how much is lost. But first, I need to know at what rate is this actually going to disappear, and so that's why I'm going to use this equation. And my T is going to be the half-life of 5,750 years. And so I get this as my K. And so now in my next piece, knowing that this right here is my K, I'm going to be substituting information into this equation here to be able to solve what the time is going to be. And so if it lost 22.3%, that means I'm going to have 77.7% remaining. So your expression should look like this. I don't know how much originally was there. It doesn't matter, because these are going to cancel out by dividing both sides by it. And I can convert this 77.7% into decimal. Then take ln of both sides. Those are going to cancel out. And so I get ln of 0.777 equals negative 0.00012t. Divide both sides by this negative 0.00012. So that's going to cancel out. So I get this statement here, enter that in our calculator, and I get t equals 2,103. So I can say that the scrolls were 2,103 years old when they were found. And so from that date that they were found, you'd have to count backwards. If you have any other questions, please leave them in the comments.